Greetings again. Here we have a small geometric problem. This one will be little easy. It is mid-level. So we have this sketch here. They want us to find the blue area, and this blue area, to find it, they gave us the difference between the two radii. The distance OS is 6, and AB also is 6√3. So we have to use that and find out how much we have left in the blue part of this sketch. Okay, well, we redrew it here, and we found that we have angle alpha to find to solve this problem, and once we have found alpha, we will be good to go. And also we have to find the radii, big R and small r. So what we know, that the difference between the two is 6, and but we have a right triangle with alpha there also. So if you have AB is 6√3, and you can say we can calculate alpha later, but let's find what r plus r is. That is OS. Okay, if you look at the right triangle, we know that OS squared is equal to 6 squared plus 6√3 squared. So that is very good. That gives us a good hint here. 6 squared, 6√3 squared gives us 144, right? And once we have OS is 144, we know that OS is r plus r squared. Where squared is r plus r squared, that is gives us 444. So r plus r is just the root of that, which will be 12 here. All right, so we have 12. We have OS is equal to 12, r plus r. Now we have good deal here, r plus r and r minus r. We can say that big R is 9 and small r is 3. So that is behind us now. Let's go and tackle the angle alpha. And still staying with that right triangle here, we can say that sine alpha is equal to 6√3 over OS. It is r plus r. Well, so simply put, sine alpha is equal to √3 over 2. And once we have that, we know that the angle with that is pi over 6, or otherwise 60 degrees. So now we know that alpha is equal to 60 degrees. Once we have alpha is equal to 60 degrees, we can say that we can find the rest of the items now. Look at the sketch very well. We have a sector. We have the first sector. That sector here is a white area. We have to calculate that, and also the small sector here we have to calculate, and the rest is double trapezoid. So it will be very simple now for us, because we have all the elements. So all we have to do is to say the sector for the big one we just showed there. If you look at the sector, it is a 240 degrees angle. So it is pi times 9 squared, that is big R squared, times 240 over 360. So we have that, and that will be that will simply give us pi times 9 squared, that's 81 pi times 240 over 360. If we simplify, we find it's equal 54 pi, sorry. Okay, and we have that, and we go back and we find the second sector we talked about, the other one on the right side here, the small circle. So A2 is equal to pi times the small radius is 3 squared. 3 squared, small r squared is 3 squared times 120 over 360. That will give us 3 pi if we simplify. So we have all that. Now we have these two sectors. The only thing, we have a double trapezoid here. If you look at the bottom from OS and then the outside to AB, and that is a trapezoid, and the other one is also a mirror of that trapezoid. So we just find it and we multiply by 2. We have that area also. So we will cover all the white area, the blank area here, and then we make the difference between that and the area of the outer circle, which has a radius, as you can see, is 12. So we get a 3 is equal 9 plus 3 over 2 times the height here is 6 root 3, so that makes it 36 root 3. Once we have 36 root 3, remember it is a double trapezoid, we have to multiply it by 2, so we have 36 root 3, and we multiplied it by 2 and we get to 72 root 3. So we have all the elements here to calculate this blue shaded area now. It is just a matter of difference between the outer circle, which is radius 12. So we can say the blue area is equal to pi times 12 squared minus 54 pi, yes, minus 54 pi minus 3 pi minus 72 root 3. So that will give us final answer of 144 pi minus 57 pi minus 72 root 3, which is definitely equal to 87 pi minus 72 root 3, and that is the answer. Thank you for watching, and see you in the next videos. Bye bye.